In the last lecture, I discussed you atoms, molecules, and ions. I discussed you uh, gram atom, gram molecule, and gram ion. I discussed this. Now, what is general formula of mole? What is general formula of mole? Here, the first formula is mole is equal to mass in gram upon molar mass. The second one is mole is equal to number of particles upon Avogadro's number Na, and third one, which is only for gas, mole is equal to volume in liter at NTP upon 22.4, which is nothing but molar volume, and also volume in liter at STP upon 22.7, it is molar volume. We can combine these three formulas. There are also little more formulas like PV is equal to nRT. I told you this is the ideal gas equation, and here this one is number of moles, but here we are not going to discuss at present this formula. We are combining these three formulas, so we can say mole is equal to mass in gram upon molar mass. This is molar mass, and is equal to number of particles upon Avogadro's number, and it is equal to volume in liter at STP divided by 22.7. This is the combined formula, but remember this particular is applicable only for the gas. This is not applicable for solid and liquid. Now after this, here we have a term which is molar mass. It is simply mass of 1 mole. Mass of 1 mole. It is molar mass. Here it is molar volume, and molar volume of gas. It is volume of 1 mole of gas. It is volume of 1 mole of gas. It is molar volume. And at STP, this molar volume is 22.7, and at NTP it is 22.4. Now dear friends, we are going to discuss this formula for the atomic form of the substance. This is we can say atomic form of the substance and molecular form of the substance and the next probability, that is ionic form of the substance. So we are going to discuss this generalized formula for these three for atomic form of substance. Here we can say number of gram atoms. This is equal to mass in gram upon atomic mass. This is equal to number of atoms upon Avogadro's number, and this is equal to volume of gas at STP upon its molar volume, which is 22.7. For molecular form of substance, here we can say number of gram molecules. This is equal to mass in gram upon molecular mass. This is equal to number of molecules divided by Avogadro's number, and this is equal to volume in liter at STP upon 22.4. I told you that this particular is applicable only for gas, and we can modify little for ideal gas. For ideal gas, the same thing is here only for ideal gas, or we can say normally for gas, because all the gases are assumed to be ideal. Here for ionic form of substance, here we can say number of gram ions. This is equal to mass in gram upon ionic mass, and this is equal to number of ions upon Avogadro's number. And here don't write this volume in liter at STP upon 22.4 22.7. This is not valid for the ionic substance. Don't write this. This is not valid for ionic substance. Why this is not valid for the ionic substance? What is the cause behind this? Actually, none ion can we have as ideal gas. None ion can we have a like ideal gas? Since none ion can we have like ideal gas, so this particular formula is not valid, not applicable for the ionic form of the substance. So remember, never apply this formula for the ions. It is not valid. Dear friends, suppose that here we have a question. Calculate number 1, number of gram ions, number 2, number of ions in 0.96 gram of SO4 minus 2. This is sulfate ion. So dear friends, first ionic mass of SO4 minus 2, here 32, it is for the sulfur, and after this 64, or I can write here this as 4 into 16, 4 into 16, and this is for the oxygen. This is for the oxygen, and these charges, they do not contribute. The charges has no any contribution in the mass. So they do not contribute in the mass. So we can say there is no effect of charge on mass, because charge arises due to the electrons. So here this calculation, it is 32 plus 64 and 96. We know number of gram ions is equal to mass in gram upon ionic mass. Mass in gram, it is 0.96 upon ionic mass 96. It is 10 to the power minus 2. After this, we also have to calculate the number of ions. So we can say number of gram ions is equal to number of ions divided by 6.02 into 10 to the power 23, which is nothing but Avogadro's number. We can say here number of ions is equal to 10 to the power minus 2 into 6.02 into 10 to the power 23. So it is 6.02 into 10 to the power 21. This is one answer and this is another answer. So remember, don't apply this formula. This formula will not be applicable here because the substance is ionic. This is ionic substance. So you can say PV is equal to nRT, or the gas ideal gas equation cannot be applied because none ion can we have like ideal gas. It is not possible. Thank you very much. Thanks a lot.